everyone, welcome to an awesome day of FileMaker training. It's Monday, and it's a third week of the launch for the FileMaker, the Claris FileMaker platform for version 22. Today is an awesome day because today is the beginning of 2 weeks of AI instruction, because there's so many of us, myself included, who have a beginning inkling of the AI, and I've done AI in so much that I sent it data, and data came back that was useful. But when you get into this models, what are models? Why are models? It's a big conversation, and a lot of us, we really haven't paid attention to it. And honestly, the first implementation of it with FileMaker 21 wasn't great. It's way better now. And so we have this week with Wim Decorte. He's a top tier developer. In fact, not only that, I think he's the manager of the FileMaker services group at Soliant. Do I have your title correct? More or less?
My title is the Chief Technology Officer. So
there you go, Chief Technology Officer. That's great. So he is actually going to shelve his super brilliant hat, and he's going to dial himself back down to like beginning and intermediate mode for this stream today, which is super great. So the goal, I'm going to hand this off to Margaret, who's there, and Wim and Jacob, and I'm going to be sitting here watching, but the goal is to be interactive, be conversational. What don't you understand? If we say something and you don't understand what that is, if you don't understand it, there's 100 other people watching the stream. There's a couple hundred people here today. There's 100 other people who have the same question, so please ask it. Margaret will see it. We're broadcasting on YouTube, Twitch, and Discord. So it's like triple cast on 3 services. Pick the one you like. If you want to be really interactive in conversation, Discord's probably the best place to be, because we see the comments in real time effectively. If you're on YouTube or Twitch, there's about a 90-second delay generally. So with that, Wim.
I think we're probably good.
As Margaret and Richard have said, I want to make this as interactive as possible, right? So we have a whole week. So I'll take you from the bare beginnings all the way to high-end deployments where we use serverless AI and everything in between. And the point is that as we go through this together this week, that you'll be able to make good decisions about where do you want to use AI, but specifically, how do you want to deploy? Where do you want to put your AI? What does that look like server side? These models that we're going to talk about, where are they? Where are they hosted? All of these things, right? So how do you pick your best server resources? So that's what we'll cover this week. So it'll be a whole trajectory, right? From the beginnings. Today we'll focus mostly on at a very high level. What is it that FileMaker offers? We're not going to demo any features. Like I'm not going to do AI from inside FileMaker. Not today. We'll get to that later this week, but I'll show you what FileMaker offers so that we can work backwards from there to say, what is it? Like, what does it mean? And then we'll build back up from there to the actual demos and the deployment for all of these things. So if you have questions, and I think Richard said it well, now's the time to ask questions, right? Because everybody's at the beginning of this AI journey, and it's so easy to make assumptions about some of these things that you'll then have to battle later. Months down the road, that will get in your way as you're making decisions around this. So now's the time to ask these questions, however basic you may think they are, right? Like they're not basic because it's all new for everybody. So ask any and all questions, and Margaret will interrupt me when needed.
Yes, absolutely. One relevant and one needed. So
exactly. All right. So I mentioned that we're going to start by showing what FileMaker has to offer, and that's it in a nutshell. There's a couple of functions that are AI related in the product as well, and we'll cover that. Maybe we'll talk about that today, maybe not, but we'll cover those. But fundamentally, the features inside the solutions, the building blocks that you will use in your solutions are these script steps, right? And we see what I mean from a functional point of view in the rows. So the left-hand side of that table, and then the models that are used to make that functionality happen, those are the columns that we have there, right? I'm not going to linger there too much, but it's fair to say that although we have 3 columns in when it comes to models, that we really only have 2, right? So we have text generation, which is the rightmost, and then we have 2 types of embeddings, text embeddings and image embeddings. I'll cover what that means and even what that looks like in a sec there, but text embeddings, image embeddings, we've already had those in FileMaker 21.0 and 21.1. So those are not new. There's a couple of newish kind of things in there, but really the big thing that is new in FileMaker 22, that's text generation, right? So that's what we have in FileMaker. We'll go back now and say, okay, what does that even begin? Like, what's AI? What are models? And start from there, right? So this is the tricky part from an understanding. I will be oversimplifying to a fair degree, but hopefully oversimplifying to the extent that it makes sense, right? So that you can begin to wrap your brain around what a model is and what a model does. But I will be oversimplifying a couple of things. In a nutshell, a model is nothing more than pure math, right? It's think of it as an extremely complicated mathematical function. It's a mathematical, and that's why I have system on the slide and not function, because it's a system more than a function, but it's really that, right? It's you give it instructions, it does a bunch of complicated math and then spits something back out, right? Specifically, what it's trained to do and what it's really, really good at, much better than we as humans, it's to detect patterns in a bunch of data. And then it can use those patterns to predict what should come next, whatever the next is, right? And if it's text generation, it's going to be what the answer should be. If it's doing semantic search based on vectors, it's going to be, okay, what is similar to what you're asking me, right? So there's a couple of different outcomes depending on what the model is trained for, what the model's purpose is, if you will. But that's really, in a nutshell, what it means. And it's really all big math. The fact that it's big math, hold on to that, because that's important when we eventually later this week talk about the server resources that you'll need, because doing high-end math is different than pure computational power that we have when we open a Word document and we write a bunch of stuff and we save it, or we create a record in the FileMaker database and we add some fields to it. That's computational power too, but it's very, very different than the high-end math that the models need to execute their stuff. Right? So of course that made all sense to you. So I don't need to explain, but
I love it, dude. What is a model? I love it.
It's like it's the same thing. When I researched this originally, and the things I had on my previous slide, like it made sense to me, right? And then 2 weeks later, I'm going like, what was it again? Like I forgot. Like it's conceptually what we're looking at here is what a model looks like. Like if you download a model, what you see here, and that's a screenshot from my Finder. It's one of my Mac. This is actually Mac Studio that runs the Claris AI model server. So if you download a model, that's exactly what it looks like. It's a bunch of files. And the bigger files are the ones here on the right-hand side, right? So these are a series of 5 gig files, because this is a 27 billion parameter model. I'll explain parameters and billions and what it means and why it matters. But in essence, that's what it is, right? So it's a bunch of files. In addition to the files, you have these are actually shortcuts that point to these bigger ones there, but they have the safe tensors extension. Think of those as big spreadsheets with rows and columns, right? And what the model can do is can go find and jump between these cells in a spreadsheet, right? So again, I mentioned that I'm oversimplifying, but I'm not too far off the truth. And then in addition to the core models, right? The big files that have all the instructions and the parameters in them, there's a bunch of configuration and JSON files that basically provide extra content for whoever executes the model. Anything that wants to talk to the model will need these ones to figure out, like, what type of model are you, and how do I talk to you, right? So some of that is in these JSON files, right? So I went from a big mathematical system to this. This is as simple as I can make it, right? A model is just these files, these big files. If you were to open them up, and you can't really open them up because they're binary, but if you were to open them up and see what's in there, it's basically all numbers. It's just a collection of numbers. And that's why the analogy with a spreadsheet isn't too far off, right? The spreadsheets are collections of numbers in rows and columns, and those numbers make sense of where they are in your spreadsheet, right? So it's the same with these models. It's just a collection of big numbers. And those JSON files and the other things, those are just basically rules and instructions on how to use that particular model.
I like that description a lot. People ask me what it was. I always said it was smart math, but this is great. I love
Yep. And one thing to consider here is the model itself and this may seem obvious, I'm going to say it anyway, the model itself has no consciousness, right? So it has no understanding. It's a dumb set of numbers.
Yeah.
It's
So let me just
extremely
spin.
elaborate pattern recognition, right?
Yeah. So people are like, hey, the AI is taking over. It's going to wipe us out, right? It's going to start, when we think about it in Hollywood and sci-fi, it's always about this consciousness, right? We have what we have, and Wim, you could correct this. What we have, we don't have consciousness, at least that I'm aware of. We have very smart math that looks sometimes like it's, aware, but it's really, really, really smart math. And the smarter it is, and the better it is, and the better the model is, the more intelligent sort of things in pattern recognition it does. And it makes you think it's, like it's aware, like it's a person, but it's not. It's just math, right? Did I have that about right?
Yeah, exactly, right. So the consciousness, the AGI, if you will, in AI, which is the next step, which is sort of predicted for late 2027, 2028, what they call the God AI, right? So the AI that will be way smarter than any human has ever been. It's on the horizon at some point, but this is not it, right? That's not that. Like this is just and Margaret said it again. I'm going back to that spreadsheet, right? Like it's a huge spreadsheet, and those instructions will tell you like if you see A2, then go to B7, right? But do that at a scale that we cannot comprehend. That we couldn't do it if we were asked to do it, right? So that's really what a model can do that. Um, at the end of the day, it's just a binary file with a bunch of numbers, and it's the code. Typically, it's Python, could be JavaScript, could be anything really. It's the code that will then interact with that model and ask it to do things. And to do things is to make these connections between those cells in the spreadsheet very, very fast and across different paths. When I say different paths, like a multitude of paths, multiple dimensions at the same time, to come up with what is really just a prediction based on the patterns that Margaret was just saying, right? It's what it does. Like you give it something, it's smart enough to dissect it, figure out what it is that you're asking. It can then predict what the outcome should be based on the input and how it's trained. Right, so that is what a model is. Now, models have been around for a while, right? Like these models that we're now dealing with, these didn't come on the scene yesterday, and at the broadest way to look at those, it's machine learning models, right? ML models. So those have been around. So we've had traditional ML models for a while. And if none of these terms make sense to you, that's fine. We've had a feature in FileMaker since 19.0, so about a couple of years, I would say, that is called Configure Machine Learning Model. It was only available on Apple hardware, right? So iOS, Apple, Mac Minis, MacBooks, whatnot, but it had to be Mac OS, where you can load a model into a container field, and then there was a function to basically give that model an input, and it will provide an output. Now, those models and that functionality that we've had in FileMaker for a while, these are not large language models or anything like what you hear about now, right? So these are still models, but they're just the older sorts, if you will. Right?
I didn't even realize these were related, so that's good to know.
Yeah. It basically did what. So this is sort of like the breakdown. The traditional MLs or machine learning models have been around. Most of those had to do with vision and image classification, right? So if you look up a lot of the old demos for the old FileMaker functionality, it was about catalogs, right? And doing some of the things that we can do now with image embeddings, and we can do it with image embeddings way faster than these things, much more efficiently. But it was really the same thing. So a lot of it was image classification, recognition, those kinds of things. So we went from traditional machine learning models to what is called deep learning models. And this is sort of where we are, right? So all of the functionality that we're going to talk about what's in FileMaker 22 is about these, right? LLMs, which are text generation models, the chat GPTs and all of that good stuff, and then the embedding models, right? The models that create vectors, and I'll explain what a vector is and all of that stuff. But that's sort of where we are, right? So it's been and these things will evolve and continue to evolve. it's evolving so quickly that we don't even know what 6 months or even 3 months from now anything that will look like, right? So, but that's sort of where we are. So if you can take your mind back to that very first slide where I had the 3 columns and 2 of them were embeddings and 1 was text generation, right? So text and I'm going to throw those together for now. Text and image embeddings, that's the stuff that we already had in FileMaker 21, right? It has only one job to do, and that's convert either text that you give it or image that you give it to numbers, right? Again, models, big collection of numbers. So it'll take the text or image that you give it, and it'll convert it to a bunch of numbers, specifically to use those numbers to look for similarities between whatever you give it and something that you ask for, or between 2 blobs of text or 2 images, whatever it may be. So those numbers are what it looked like. And this is in real terms what an embedding or a vector looks like. And I know people use vectors and embeddings as if they were the same. They're not really the same, but they're close enough that we shouldn't care what that means. But this is what it looks like, right? So if you use any kind of functionality, including the FileMaker functionality, to say, I forget what the exact script step is called, but it's called something like insert embedding or something like that. And there's a bulk version of that too. Or there's even a function that says get embedding. So when you do that, you say get embedding, here's text, embed that for me. What the model will spit out is this, right? So we're now not looking at the model, we're looking at the output from the model, which is, and you can see that here at the first character, and it didn't show the last character because it's really long. But the first character is a square bracket, right? So it's an array of numbers. And you can see some of them have minus, some of them have plus. Every number in this array is between -1 and +1. And it means it's a scale, right? So every number in this array is a nuance. That's probably the best term that I can think of. It's a description from something, right? If I translate this into terms that we as database developers are familiar with, right? Like you create a table. You create a table called books. And you start adding fields to that table, right? One of them is going to be author. You may have a subject. You may have a summary. You may have something that is, well, the title, right? Things like that. So in database terms, we call them attributes, right? Or columns. Every single one of those describes the noun, right? The noun is book. And your fields describe a particular aspect of that book. And the more fields you have, the more nuances you have or descriptors of that book. This is the same thing, right? Every number in this array is a description of what you gave it. And let's keep it simple and say you gave it an image, right? So every number in this array describes that image in one aspect, right? And it could be indoors or outdoors, or just call it indoors, right? So if it's indoors, it would be +1. If it's outdoors, it would be -1. So based on the model's training, it'll look at that picture and say, I'll give that a number between -1 and +1 based on what I think, whether it is indoors or outdoors, right? Or it could be dog, right? Does this picture have a dog in it, or cat, or animal, right? So I've already had indoors, outdoors, cat, dog, animal, 5 nuances, something like that, right? So I can keep going, right? Like colorful would be a nuance, or anything like that, right? So a text or image embedding model has a predetermined set of numbers that it will spit out. The more complex numbers will give you more numbers, basically more nuance.
Mm-hmm.
It'll also take more time to generate because it got to look at all these things in 400 different ways instead of 100 different ways, right? If the model is set to spit out, these things are called dimensions. Every single number here is called a dimension, right? So if it has to spit out 100 dimensions, if it has to look at a picture and come up with 100 dimensions, that's going to be faster than if it had 500. That's pure, again, that's where this math comes in, right? So with me so far, so this is the only thing that an embedding model does. It takes your input and it spits out an array of numbers.
Okay.
Each number is a dimension or a nuance, a scaled nuance, or basically like almost like true or false, which is not because that's 0 or 1, but it's more granular than that, right?
Yes, this finally makes sense. I've seen this before a couple times. People have mentioned it, but I am finally beginning to grasp what you're telling me here, which is that essentially every image has a series of nuances or descriptive terms that you could assign to it, and we're just converting that into mathematical numbers. And the closer the numbers are together, the similar the more images are, or the more similar the images are, and the farther apart they are, then that means that the images have no similarities between them. Okay.
Yep.
That,
Yep.
okay.
Yep. If this first number was say dog, right?
Uh-huh.
Then a score of 1 would say, or closer to 1 would be, the model would say there's a very, very high probability that there's a dog in this picture, right?
Mm-hmm.
If you then give it another picture of another type of dog, right? The first number would similarly be closer to 1 than closer to -1,
Mm-hmm.
right? If I then ask through the FileMaker function, like I give it this one, a picture of a dog, and I ask it, find me all the Henrys that Henry is a dog, that I have in my database. It
Mm-hmm.
would then look through all of the stored arrays of numbers to say, of that first number, which one is closer to 1, right? Because those would be dogs, right? So
Mm-hmm.
in essence, in a simple term, that's then how semantic search would work, right? Because it can then look at all of, but it looks at all of them at the same time, right? Instead of just that one example that I gave you, but that's how that works.
Okay, cool. Yes, that's making sense.
All right, we'll stick with the topic of embeddings, right?
Mm-hmm.
So we'll visualize that a little bit, and we'll step through the process of both the embedding and the searching on those embeddings, how that works, right?
Okay.
So I mentioned we have a bunch of pictures, right? So and every one has been vectorized or embedded. Again, vectors, embeddings, not quite the same, but close enough that we shouldn't care. So when you see vector, think embedding, think array of numbers, right?
Got it.
So all of these have their because you got to do that. Like before you do semantic search on whatever it is that you're searching on, um, you have to have these embeddings pre-generated, right? Because otherwise
Yes.
it would be horribly slow if you have 100,000 pictures and I'm asking for give me all the pictures with a black lab in them. Like you wouldn't want
It would
to
have to sit
generate
there
all
and
those
generate the
embeddings.
embedding and then look at it to see if it even matched in the first place, and that would take
Exactly,
ages.
right?
Yeah, okay.
So
Mm-hmm.
you generate those ahead of time. And I'll show you an example. If not today, then tomorrow we'll get to the actual demos. But that's what it is. You store those, and actually, it's a bit of a segue. But again, kind of important to plant the seeds right now because this is all new. Storing these arrays, FileMaker can do that, right? Because in essence, an array is nothing but a chunk of text. It looks like a lot of numbers, but it's a big chunk of text.
Mm-hmm.
Now, if I have 100,000 records and each one has this big array of 500 nuances for that stuff, that's quite a bit of text and data to store, and then doing searches on them. Obviously, the faster the database engine is, the faster that the results would generate, right? So there's
Mm-hmm.
a whole new database world opening up of what is called vector databases, right? Types of databases, and they could be variations of existing databases, like Postgres, for instance, is doing a lot of work on this, that to create specialized databases to store these vectors and retrieve them and do math on them real quick,
Got
right?
it. So it
So,
doesn't do anything else that does that specifically. That would make
yeah,
sense.
yeah. So at this stage, we've generated all of our embeddings, right? So we have all of these arrays pre-generated. The the step number 2 and 3 here are really they're meant to convey that a model isn't a single thing, right? It's think of it as different layers within the model, and each layer has a specialized task, and it hands off the tasks to the other layers, right? So if you take a picture, for instance, the first pass through the picture could be, for instance, um, find me all the different colors, or the second layer may be then find me the shapes. Like I don't care what the shape is, just draw the shapes on that. And then the third layer would be like for each of these shapes, try to recognize it. Is it an animal, human, like stuff like that? So there's a progression in the model as it looks at these things, and it stores some of these things in those different dimensions as it finds them, right? So this is what it begins to recognize: textures, shapes, all of these things. And this particular thing doesn't do it a lot of justice because an array, and that's why they call them dimensions, right? Like it's we're used to thinking in 2 and 3 dimensions because the 4th dimension time is kind of difficult to visualize. But really, an embedding, and you have embeddings in like 380 dimensions, 512 dimensions. Think of them as each of these dimensions going in a different direction, right? That whole scale. And some of those are really close to each other. Like the dimension for animal and the dimension for dog would be at like a narrow angle, right? They wouldn't be the same. They would be offset, but they would be close enough because they are related. Whereas animal and house would probably be like, well, I can't do my arms like that, but it would be like this. Like
Yes.
one would go this direction and one would go that direction, right? So they would be totally opposite,
Yes.
right? So, and the colors don't come out in this screenshot, but or in this visualization, but that's what it meant to convey, right? Like they go off in different directions. This is how the semantic search then happens, the cosine similarity, right? So for each of those dimensions that you have in that big array, it'll try to calculate what the angle is between the first number in the picture array and the first number in what I'm searching for.
Oh. Okay.
And
So
it does
that's how
that
it
for
determines
all
difference.
512 of those, right? To say
Oh.
how wide is that angle? Because the again, animal dog, right? If that angle is close, it means that the picture that I gave it as an example is close to the picture that it's looking at now, and it's got to repeat that for all 100,000 records.
That's a lot of math.
It's a lot of math. Exactly. You're getting the point that this is the kind of stuff that our human brains just can't cope with that, right? Like not at the speed that we would have to do, because none of this is none of this is out of this world. Again, this doesn't have consciousness. This is all math, right? Like if I sat down with a ruler and a pen, I could do this. Like it would take me 20 years probably to get through it, but I could do it, right? Like it's this is nothing that our human brains couldn't do. Models can just do it faster and more accurately.
Okay, so that makes a lot of sense.
Right.
There's a question about the vectors real fast.
Yeah, go ahead.
The vectors is what the semantic search stores in the records?
Yes. Yes, that big array, do I still have it open? Right, so this thingy here, that's the vector or the embedding. Again, I'm using the same thing for not quite the same thing, but this is literally what you store. Now, FileMaker can store it like this as text, which you wouldn't want to do. FileMaker can also store it as a binary, which is a lot more efficient. So it goes into a container. But yes, this is what you, for each photo in your catalog, you would have this stored on the record. I would typically use a related records and have it in its own table and probably in its own file for that matter. But conceptually, for each record, it's even for each field, but typically you would only have one picture per record in your catalog. So it would store one of those for every record. And again, you would generate those ahead of time, right? You'd pick a model that you're happy with. You've done some testing, and we'll talk about testing and picking models this week a lot. But you pick a model, you do your test, and then say, I'm happy with the results that I get from this model. And then you let it loose on your database. So it goes that generate those 100,000 records, those embeddings, right? But yes, that was the.
There you go.
Right, so when you do that kind of semantic search and it goes through all of those and measures the angle between all of those dimensions and nuances, at the end of the day, it'll come up with a similarity score, right? And so that's the bigger the number, the more similar that things are.
Bigger the angle between them. Yeah, okay.
Yep. And some things to consider there, right? So most of these things are this, right? So obviously I'm using images as an example, but this works as well with text, right? As long as the text has a story, right? Remember those nuances, like the 512. The bigger models have like 512 dimensions. I'm sure that there's bigger ones. Some of the models that we typically use with FileMaker would have 380 or something like that of those dimensions. If I were to give it a word like dog, just to stay with that one, there's not a lot of nuances that you can assign to the word dog, right? Like if it's a picture of a dog, then yes, right? Because you can look at like things like is it what color is it? How big is the dog? What breed do I think it is? But if it's just the word dog, that's really not a good use of semantic search because the word dog doesn't tell a story, right? Um, if I'm a dog breeder, or if I'm a kennel or something like that, or a rescue organization, and I have pictures of my dogs, but descriptions of the dogs, then it would be this is a dog of this breed with this name. It's a very social dog, gets along with cats. Right? So that's a block of text that tells a story. That is a very good thing to embed because there's a lot of nuance to the story, right? So semantic search against text would not be something that you do on fields like first name, last name, city, right? That's really not what it's meant for, right? Because these things don't tell a story. However, if you have a customer, you can create a story to say, connecting that, or Soliant Consulting is a company based in Chicago. They do this, that, and the other thing. They have great people on staff. We worked with them in the past on 5 projects. This summary becomes a story that you can then embed and have a lot of nuance assigned to that, right? So images are a much better natural fit for embeddings than text. Text would have to be a story before it becomes meaningful for any embeddings and does semantic search.
Okay, that makes sense. If a semantic search is made locally, wouldn't it be necessary the embedding? Are you asking about the pre-generation not being necessary if it's local? Yes. It's still a lot of analysis to do, isn't it? Even if it is local?
Yeah, if it's local, like if you well, just to make sure that we're all on the same page, your FileMaker file, your photo catalog FileMaker file doesn't need to be hosted for any of this to work, right? Absolutely not. Like FileMaker server has no play in this whatsoever, right? It's locally, when you run something locally in the FileMaker script, it will call an AI model wherever that AI model is. And we'll get to that this week a lot again, right? Like where do you deploy AI models? Where are they? How do I talk to them, right? So if you're local, if you don't have the FileMaker file hosted on the server, you're running this locally, it still needs to reach out to a model, right? That model, you can deploy that model on your own machine. You wouldn't want to do that, but on a machine close to you, like it doesn't need to be in the cloud or anything like that, but AI model has to be hosted somewhere for you to talk to, right? So if you don't pre-generate your embeddings, your vectors, right? That big array of numbers, there is no way that you can search across multiple records and have a result. There is a way that I can see that you could do this because there's a function where you can say visit this record, grab the picture, get me the embedding, and then compare it to the embedding of what the picture that I gave you to search on. You could do that. It would be horrible, right? It would work. Like theoretically, it would work, but you would never do it that way. So I guess the difference between local and not local, I interpret that as hosted, not hosted. So maybe I'm off, and
Yeah,
whoever asked the question can ask again.
they're saying if the model is local. So I guess if you have the model stored on your computer and then you searched on it.
Yeah.
Yeah.
The model being local versus using OpenAI, Cohere, Anthropic, what have you, makes no difference, right?
Hmm.
We'll come to models in just a sec. We have enough time to show like the beginnings of where you pick a model. the main difference would be that if you want to be in control, which I think you should, of your models, because you're going to be sending data to your models, you want to know where you're sending your data to. Typically, it means that you have your pick of models that you can run locally versus the commercial providers. Commercial providers use their own models. Not all of them are available to run locally. So again, I mentioned testing already. We'll talk about that because if you want to run locally, you'll have to go through the models that are available to you, pick the one that gives you the best results at the best speed. But having the model run locally makes no difference in the functionality. It functions exactly the same way.
Okay, we have a question about the similarity scores. You get the similarity score regardless of which image is query and the comparison. It shouldn't matter if they're reversed. So if I start with one Labrador and then I use that as like the base image search to compare against the other one, they should have the same angle between them no matter which one starts, right?
Yes, absolutely. Yep. The actual number, the end result may vary just a little because it looks at all the dimensions, but it really makes no difference what the look for and look in is when it comes to comparing two individual embeddings or pictures for that matter.
Okay. I think we're good to keep going then.
All right. So we talked about this, right? So text and image embeddings. On to the next one, the newer stuff that is supported in FileMaker 22, text generation models. They have a different job, right? Their job is to generate text output and to make that text output as human-like as possible, right? So instead of generating a big array of numbers, they actually generate text, right? So you ask a question, and it'll generate text for you. The embedding models, their output is constrained, is fixed, right? Like it's depending on the model. The model say, I'm giving you 384 dimensions, or I'm giving you 512 dimensions. Text generation is different, right? The length of the output is variable. It kind of depends on complexity of your question, what kind of data the model has as available. But in essence, text generation does just that, right? It generates text. And that's what that does. So oops, let's go into how that works, right? So text generation models are called large language models, right? The language in LLM is important, right? Because again, they're meant to sound human-like. So how do those work, right? So they have this notion of context, and the context is what it has already produced in essence, right? So if it has already produced, and I'll give a full, more conversational example in a sec here, but in this case, the context is these 5 words, right? The cat sat on the. That's the context. That's what it already knows. To jump ahead, all text generation models do, and remember what I said at the beginning, this is all about pattern recognition and predicting what comes next. LLMs or text generation models are really just great at guessing what the next word is. That's all that they're good at, right? Again, no consciousness, no intelligence as we know it, right? They're just really good at figuring out what the next word should be, right? And they rinse repeat, right? So they'll try to guess what the next word is, and then the context becomes 6 words, and then they'll guess what the next word should be. And they do that really, really quickly. So this is really all about statistics, right? So again, as a human, we could figure this out. Give me a good body of knowledge that says in the English language, and of course they do this across multiple languages, but in the English language, which words usually follow that word, right? Or if you take the words of Shakespeare, what's the most common word? Because that's easy to guess, right? Like if the or a is the most common word, it's going to be high on my list of predicting what the next word is going to be, right? Like I'll go down my list of what the next word could be, right? So if you remember one thing from LLMs, that's all that they do. They guess at the next word, and sometimes they get it wrong, right? But that's what they do. They do it in a very complex way, right? So they look at this context, and again, the context is these 5 words, right? Before the word that it has to guess at, right? So this is the context. Then for each thing in this context, it looks at what the attention is. Like, what's the relationship between those two words, right? And it's color coded to say the ones that are more red or darker colored or are more likely to have a relationship between each other. Right? That this is what they call the attention mechanism. It's important to them or to the model, right? Because words that are that have a good relationship between them, it can use that. It can focus on those to say, in my big database, if you will, of words that follow another words that have a close relationship to it. Those would be the ones that I prioritize to look up what the next word would be, right? Like words that are totally unrelated, I can forget about now. I can not spend a lot of time on that. And again, sort of this progression here, again, that's the layers that every model has to say, start with this, then move on to next thing. Like if you've done this task, then move on to that task and do that, right? So the next layer is that understanding, right? Like that context. So the fact that there's the word cat sad means that it's that there's an action there. So it can then go look like, do I see an action in that, and that can help again with narrowing down that, because there may be a list of 100 words that statistically are more likely to come up as the next better word. So it's got to have to find a way to dwindle that list to the most plausible one, right? And again, at the end of the day, it's just a probability distribution, right? It's going like, I came up with these 3 words. I'm going to pick Matt and hope that that's the one that you were after, right? Because it's the most probable. And this is where models sometimes get it wrong, right? Because maybe you meant chair, or chair was the answer you were looking for, but in all of its complex math and probability, it came up with the word math, right? And then it figured out that that's what that is. And then it repeats that, right? Like now I have 6 words that are my context, and it'll go on the job of guessing what the next word after that is. Right? So same example, but more geared towards what we would typically expect of an LLM model, of having a conversation with a model, right? It's I have a question, and really the only difference here is these things, right? Like user and assistant, right? My whole question becomes the initial context, right? To say, okay, model, this is what I gave you. This is the context. Now go figure out what the first word is of the answer based on my question, right? So it's exactly the same process as I just gave you, but the context becomes my question, and the break between what my question is and what the model has already generated is that user and assistant.
Oh, interesting. I always wondered how it knew that. Okay.
Yeah. So it knows what it generated, and it knows what you asked, and that's how it does that. Right? And then basically just goes through that same process to figure out, okay, well, the is probably the first word that I should come up with, right? And then move on from there. But again, every guess is a guess, right? It's a probability of what it should be until it gets to the answer. Right?
Okay.
This thing is key, right? In all of this. Right?
Interesting. Yeah. Okay.
The model doesn't sit there and say, I'm going to give you an answer. Well, I'm actually not sure how to describe that, right? As humans, we would think and come up with the answer as one go. Like we wouldn't go word by word. Like we wouldn't say, what should be the first word of my answer, right? Like we would jump to, do we know what the capital of France is? It's Paris. And then we will build a sentence around the word Paris because we know Paris to be the right answer, right? So the model, again, no consciousness, like we humans, like it doesn't have human intellect, right? So it'll just start by the first word and then build from there. But it doesn't plan the whole answer. It doesn't start with Paris and then builds a sentence around Paris.
Yeah. Okay. So it doesn't necessarily know the answer. It knows roughly what the first word should be, and then it looks at the information that you asked it to go looking for what the next predictive word to be until it arrives Well, it doesn't even realize it has the answer, right? It finishes up the sentence and the sentence feels like it should end, or rather the pattern determines it should end, and then it spews it back out at you, right? Is that essentially what's happening?
Yeah, in essence. And again, we're simplifying a bit, but yes, it is, right? So remember, we asked the question, what's the capital of France, right? So it knows from that relationship between those words in our question that capital and France are probably becoming closely related, right? So when it comes to paying attention to what would be a word that fits those two things, capital and France, it'll come up with Paris for that combination, right? So it's not that it knows ahead of time, but it bumps it up in the probability list of words to be picked, right?
Okay, that makes sense.
All right. Any questions on that stuff?
We have a little bit more of an advanced question about embedding, but I don't know if you want to like put a pin in that for a later discussion or tackle that now.
I would say read the question and we'll see whether we.
Yes. Why separate out the embedding table from your files? Container data being embedded table.
We'll come back to that question in more detail, but the answer to that is really a FileMaker question, right? Because the array is a big chunk of text, right? If I store it on the record, and we know from experience that FileMaker always works with a complete record.
Mm-hmm.
In my normal FileMaker interactions with my record, I don't want to be schlepping around that array all the time, right? So that's reason enough to not store that on the record, right? Because if I have users doing normal queries or bringing up lists of records, right? I don't want my client and FileMaker server like communicating with each other, and all that record data includes that big blob of thing that I will only need for semantic search. So that's a reason why I would separate it into a separate table, a related table, so that I can do a search and then get back to the core record. So that's a reason for having its own table. For having its own file, that has to do with performance. And I've given talks about this, right? Don't create monolithic single FileMaker file solutions. Just don't do it, or I'll come haunt you in your sleep. Once you creating these vectors is typically a one-time deal, right? You figure out what model you want to use, you generate them, and after that they remain static, right? If they are stored in their own file, you get a lot of benefits from backups, right? Because that file doesn't change, so FileMaker will hard link it when it does a backup instead of having to find disk space for it, wasting time on copying it over, right? So that's a reason why I would make it a separate file, right? So there's two optimizations when it comes to speed and performance. One that is a little more FileMaker server related, but one that is very much day-to-day FileMaker record related.
Got it. Okay.
And that's probably going to be the last thing for today, but it's still fundamental to models, right? We mentioned text generation models, embedding models.
Mm-hmm.
For the embedding models, I've already said that they have a fixed output, right? The length of that array is predetermined. You have no say in that.
Mm-hmm.
And this is one of those embedding models, right? It's actually one of those that comes pre-configured with the Claris AI model server, and you'll see that tomorrow or the day after, right? It's a model that's used for sentence similarity. Makes sense because it's an embedding model. And here in the description, it says it maps sentences and paragraphs to a 384-dimensional dense vector space. That's a lot of fancy words to say. My vector is 384 numbers long. That array is 384 numbers long, right? So I mentioned 384 a few times. I didn't pull it out of my behind. That's where it came from.
Got it.
Right. So that is one aspect, and that's dimensions, right? Again, dimensions is the number of nuances in your vector, in your embedding, right? Like how many of those lines go in every which way direction. The other one is this one here, right? The model size. This one is 33 million parameters. Right? So think of it in this way, right? Parameters are the complexity of the training. That's how I was going to say intelligent. I've just said that models are not intelligent. So I'm not going to use intelligent, but It speaks to that complexity of training. How intensive was the training? That's the number of parameters. The number of dimensions is just the size of the output, right?
Okay.
And the bigger that array, the more complex the output, the more nuanced the output is.
So as an example of training, would like, for example, like the more parameters you have, the more times that it associates the with a variety of different words, like the more words it has in relationship to it? Is that what a parameter is? It's got more, is it making more connections between different not concepts.
Connections is a good word for that, right? So those models, when I made the spreadsheet analogy, right, with rows and columns and the ability to jump between cells,
Mm-hmm.
uh, you can think of those as nodes, right? Like the more nodes it has to jump between, and those are predetermined too, right? By that training, like that spreadsheet, somebody generates that spreadsheet, generates the model, right? So it only has those again, and it's an oversimplification, but I kind of like the spreadsheet thing, right? The
Mm-hmm.
number of rows and columns, the number of cells in your spreadsheet, that's your billions of parameters,
Ah, okay.
right? And that means that there's more points to jump to look at. Like if I'm here, I can go there. If you only have 33 million of those, that's it, right? Like it can only
It's not
jump.
generating new nodes or new cells in the
Does not.
spreadsheet.
Yeah, yeah. It's like a human brain. Again, no consciousness, no intelligence whatsoever. But our human brains have neurons and paths between neurons, right? It's
Mm-hmm.
something the same. But think of them as those cells in the spreadsheet, right?
Got it. Okay.
And when I mentioned like it jumping between those cells in the spreadsheet, those are pathways.
Mm-hmm.
If you ever looked at a print plate, like if you ever took something electronic apart, and then there's that green baseboard with
Yes.
like paths on it, right?
Uh-huh.
So models can do the same thing. They have paths, right? So when I say it's a mathematical function, those instructions can say start here and take a path that goes there, right? So it's sort of like that same thing. But it can only take so many paths because it only has so many parameters,
Got it. Okay.
right? So we're looking at an embedding model. Embedding models, when you go explore embedding models, they will always emphasize the number of dimensions. They will never emphasize the number of parameters. The reason for that, I guess, should be a little obvious based on what we talked about, right? Because it's the dimensions that determine the size of the outputs, the level of nuance in the outputs, right? More is better, right? If I have 512 descriptors of a picture instead of 384, there's a better chance that if I go look for something, that I'll find something that is similar. That's really just what it is, right? So embedding models will emphasize dimensions, whereas so you get these two things. I should look at my presentation though. So dimensions, parameters. Now, text generation models, and that's a card for that Gemma 27 billion parameter thing. The one that I just showed you had 33 million parameters, right? This one has 27 billion parameters, right? Um, but this is a text generation model. So the only thing that they can emphasize is the number of parameters. They cannot emphasize the dimension of the output because the output is variable. It's a
Mm-hmm.
it's a conversation, right?
Mm-hmm.
The answer may be 2 words, or the answer may be 200 words, right? So they can't very well use dimensions as a measure of how good the model is. The only thing that can use to explain how smart the model is the number of parameters, right? The number of cells in their spreadsheet, right? So that's what it is. This is also the beginning of the difference in size of model between an embedding model and a text generation model, right? 33 million, 27 billion. They got to be stored somewhere, right? Yeah.
Yes.
So a text generation model is going to be way bigger than an embedding model, and we'll see that later. We have about 5 minutes left. I think we should stop here with this one and field some questions.
Yes. We've got a couple questions floating around. Can we get the keynote or a link to the resources?
Sure. I'll probably do that at the end of the week because it's a work in progress based on the questions. But yeah, I have no problem with that. I can send you that.
If it is a container, does FileMaker also send it down? I think this is a question in the middle of our discussion about the containers and storage.
Good question. It's varies by FileMaker change behavior there, and maybe Jacob can fact check me. Containers typically do not travel with a total record size. So that would be one argument against what I said earlier. I still wouldn't store it on the same record though, right? I want to have that separation.
Yeah, I agree. Also, one, I don't know, input or fact that was part of that context was we were talking about local usage in models. And so you may have been thinking about addressing local pro and dragging containers around like you're doing the embedding locally on your computer in pro or something like that, and the file's local, it's not hosted, etc. So
okay. Yep. A little known fact there, when you have containers like this and you would have one for each record, again, if you have 100,000 record photo catalog, use remote containers, right? The FileMaker is way faster at retrieving remote container data than embedded container data. I don't mean embedded in terms of AI as we talked about, but basically a binary stored in a global field in FileMaker. Because remote container data, that whole functionality is more recent than the old school storing containers. The engineers have optimized that, so it's much faster.
Yep.
Could you load DeepSeek LLMs into FM server?
Good question. This is going to be a quick hint preview at some of the things that we will be talking about later when we talk about models, right? So Hugging Face, we'll spend a fair amount of time on Hugging Face because it's the de facto repository for a lot of these models.
Mm-hmm.
I will actually explain which models you can use for text generation with FileMaker and which won't work and the reasons why, right? So DeepSeek, I actually haven't tried DeepSeek, so maybe we can try together this week when we set it up. There's no reason why it wouldn't work. However, there are some constraints, and I'll explain later in the week what those constraints are. So when you go looking for a model, that you'll be able to pick the right task among all of these available tasks when you set out, and also what libraries, because that's probably the single biggest qualifier for writing the right model. It's the fact that it has to be a transformers library, right? So if the model, like if DeepSeek was only, say, Safe Tensors model or one of the other ones, then, and most of these terms, by the way, will get explained this week, right? MLX, GGUF, what they all mean. So we'll talk about that. So, the answer to the question, the TLDR is, I don't know. I haven't tried DeepSeek, but it'll be interesting to find out. But you can use models from different providers for sure.
Kind of a model-related question. Hi, this is Marcel, and I have this question. We currently use OpenAI's Assistant API from FileMaker, where we create a thread from an email's content and run different pre-configured assistants on that thread like a Swiss Army knife. Can the generate response from model function be used for this, or is it strictly limited to the chat endpoint?
That's a really good question. Actually, we'll start there tomorrow because, and another quick preview to tomorrow, that generate response from model is nothing but a fancy insert from URL. It really,
Okay.
and I'll show you tomorrow. I'll prove it to you tomorrow, right? So if you have an OpenAI endpoint that you can use, it's just an API integration. And again, I'll show you that in detail tomorrow. We'll start there tomorrow. So if the generate response from model doesn't work, because that one, again, it's a fancy insert from URL, but it's pre-coded to the v1/chat completions endpoint, the OpenAI. It's a different endpoint for Anthropic. So you wouldn't be able to use that one, but you can use insert from URL without a problem. One caveat, but I will not reveal the caveat until tomorrow.
Probably for the best.
Well, we want people to come back, don't we?
Yes, we do. Many thanks. And a lot of people thank you for the really excellent explanations, which is very true. Like, they were fantastic. I understand this a lot more than I did literally an hour ago. So, thank you very much, Wim. I look forward to seeing you tomorrow and seeing the rest of you here tomorrow.
Absolutely.
All right.
Bring your questions.
Yes, please do. Bring your questions, comments, concerns. All right. Have a good one, everybody. I will see you all later. Bye-bye.
No.